What is a solid solution? A solid solution is a homogeneous mixture of two or more elements in a solid state, where the atoms of element are dispersed at random in crystal lattice of others. The solid atom can either substitute for the solvent atom or fit into the space between the solvent atom. Second one is solid solubility. Solid solubility refers to the maximum amount of material that can dissolve in another material to form a solid solution. The solubility depends on a factor such as atomic size, difference less than 50%, crystal structure, and electronegativity. So the example of solid solution is steel, bronze, brass, and gold.
Hi guys, my name is AMIR HAKIMI and I will explain about interstitial diffusion. Interstitial diffusion is the movement of small atoms or ions through interstices in a crystal lattice. The significance is it will affect properties and behaviors of materials, especially metals and alloys. Diffusion species for common atom is hydrogen, carbon, nitrogen, and oxygen. This is because small size allows them to fit into interstitial sites. The mechanism that it uses the atom move from one interstitial site to another. The driver is concentration gradient, temperature, and thermal vibration. For activation energy, interstitial diffusion has lower activation energy compared to substitutional diffusion, so it can happen rapidly. This is because less arrangement of the crystal structure required. The applications of diffusion is first carburizing, it means adding carbon to steel surface for hardness. Second, nitrizing is adding nitrogen to steel surface, and lastly, hydrogen embrittlement is hydrogen diffusion causing brittleness. The factors that affecting is first temperature. This is because higher temperature increase diffusion rate. Second, concentration gradient. This is because higher gradient increase diffusion rate. Third, crystal structure. This is because type of lattice FCC, BCC, HCP affect diffusion. Lastly, lattice strain. This is because strain impact the atom movement. So that's all from me, thank you.
Next, we are going to talk about substitutional diffusion. Atoms in a solid state material, such as metal, are arranged in a regular lattice. In substitutional diffusion, an atom moves from its original lattice site to a neighboring vacant site, a vacancy. Substitutional diffusion only happens if there is vacancy. Vacancies are naturally present in crystalline structures due to thermal vibrations and can also be introduced during material processing. For an atom to diffuse, it must find a nearby vacancy to move into it. This process is driven by thermal energy, which allows atoms to overcome the energy barrier for migration. As atoms move into vacancies, the vacancies themselves effectively move through the lattice. The overall movement of diffusion is called flux.
Eutectic reaction. A eutectic reaction is a three-phase reaction by which, on cooling, a liquid transforms into two solid phases at the same time, which is an isothermal reaction. The simplest equation that I can make is L equal to A plus B, which is L is solid liquid equal to alpha solid and plus beta solid. There will be four main phase diagrams that need to be known, which is eutectic, hypoeutectic, and complete solution composition. The complete solution composition for both alpha and beta solids in microstructure are the same, just different material. The phase diagram of the microstructure in eutectic reaction will involve liquid solid, pro-eutectic alpha can be beta also, and lamellar structure. These are four main diagrams, which is complete alpha eutectic composition, hypoeutectic composition. You can see there are pro-eutectic and the third picture, which is pro-eutectic, and then in the fourth picture, it became two solid, which is lamellar structure and alpha. In summary, eutectic reactions are unique and important type of phase transition that occurs at a specific composition and temperature. It will take in simultaneous solidification of multiple phases and application across many fields.
I'm Danish. So now we are gonna talk about eutectoid. It's very similar to eutectic because it is a mixture of substance similar to a eutectic, but forming two or three constituents from a solid instead from a melt. As you all can see, we will start with the significance. An eutectic reaction is a three-phase reaction by which, on cooling, a liquid transforms into two solid phases at the same time. For example, liquid alloy becomes a solid mixture of alpha and beta at specific temperature. From the diagram below, we can see that eutectoid is stabilized in the middle of the diagram. The eutectoid is between two phases, the left and the right one, but about it, we will explain in the next part. Beside it, you can see a diagram or a graph for the cooling process for eutectoid. We start with liquid mixture cooling, and it will stay constant at isothermal solidification of eutectic composition, and it will become a solid mixture freezing. That is for eutectoid. As you all can see, eutectoid microstructure. And eutectoid microstructure forms when a material with a eutectoid composition cools down through the eutectoid temperature. In steel, the most common example is pearlite. The eutectoid microstructure significantly affects the mechanical properties of the good material. In steel, pearlite provides a good balance of strength and ductility. For the composition, an eutectoid composition is specific mixture of elements that transform into two different solid phases at a certain temperature. As you can see, it is in the middle and it is 0.77% carbon. While in the middle is eutectoid, the left one is hypoeutectoid and the right one is hypereutectoid. Both of them have the almost same cooling system, because when you see at the graph that will be provided, it is just the same for each, but hypoeutectoid requires alpha and hypereutectoid requires beta for the cooling part. Also, for the process in everything for this hypoeutectoid and hypereutectoid. Now we go to the composition. When we see about the eutectoid, it is the mixture between alpha and beta. But for hypoeutectoid, the composition requires only the alpha, while the hypereutectoid composition requires the beta. So this shows us that it's very two different things, and it is the divide between eutectoid to become hypo and hyper.
Peritactic reaction. What is peritactic reaction? A peritactic reaction is a type of reaction in a phase diagram where a solid and liquid phase combine to form a second solid phase upon cooling. This occurs at a specific temperature and composition. The general form of peritactic reaction can be written as liquid plus solid 1 produce solid 2. In a phase diagram, the reaction is represented at the peritactic point, where the liquid and the primary solid phase coexist and transform into a secondary solid phase as the temperature decreases. An example of peritactic reaction can be found in the iron-carbon system, where delta ferrite and liquid iron combine to form arsenic at a specific composition and temperature.
Hello, my name is HASRUL. I will introduce to peritactile reaction. In a material science, a peritactile reaction is a type of solid phase transform that occurs in some alloy and compound. This reaction involves the transformation of two solid phase into a third solid phase upon cooling. General form is alpha plus beta equals to gamma. For the key characteristic of peritactile reaction is, unlike peritactic reaction which involve a liquid phase, peritactile reaction occur entirely in the solid state. This reaction occurs at specific temperature composition in the phase diagram. The resulting monostructure can be complete due to the diffusion of atoms in the solid state. The driving force for the reaction is the reduction in gaps in free energy, and the kinetic of reaction are controlled by diffusion process in solid phase. For example, a classic example of peritactile reaction in the FECR-NI system, which is important in steady state. At a certain temperature, two solid phase such as austenite and sigma phase can react to form a new solid space. New solid space like ferrite. For application, understanding peridactyl reaction is crucial in material design and processing, particularly in alloy development and heat treatment process. Control over this reaction can lead to desired mechanical properties and phase stability in the final material. Thank you.